Welcome to part 1 of Intro to Predictive Modeling. So in this module, you will learn different types of supervised data mining techniques. And let us begin with this simple example. So say you work for a big telco and your job is to make a predictive model of customer churn. So your task is to devise a step-by-step plan for how the data science team should use the company's vast amount of data resources to address the problem. So, what data would you need and how would they be used? And how should the company choose a set of customers when they conduct a customer churn prevention campaign? How do they choose a set of customers to receive their retention offer, for example, in order to best reduce customer churn for a particular, within a particular sort of budget constraint, right? So budget is limited, so so the budget is restricted. That means you cannot send the retention offer to everyone. You have to carefully select a set of customers who are most likely to respond to it. As a result, they do not leave. So that's the setup. And this diagram says and depicts the step-by-step plan. So where do we begin? We begin by defining our target outcome. What do you mean by customer churn? So we can certainly encode it as customer churned, what customer left, what customer still with us. So we can define it as a binary outcome within a particular or specific time frame. So in the past 3 months. Then we begin by defining our target outcome. Say, what do you mean by churn? Right? So it's the termination of current contract. We should specifically define what is and how it is defined, and we have to operationalize it in terms of how do we measure it. Then we operationalize the variable. In other words, we have to clearly define how we encode it. So say we're going to create a customer churn variable, and that categorical variable will take the value of 1 if customer left, otherwise 0. Right? And then we split our original data set into 2. One, a training data set, the other, a validation or a test data set. So that's what we discussed earlier. So we split the data, a certain a fraction of it for training purposes and the rest for validation purposes. So only the trainings that enter the model when we train and when we develop our models. And once we train them by using the test set, we perform model comparison to see which one works the best. Is logistic regression better than classification tree, or classification tree is better than a neural net? That's what we do in the stage of model performance comparison. And after this, we can pin down what the winning model is. Once that is identified, then we bring in the unknown data set. What do you mean by unknown? The value of target is unknown. That's exactly what we'd like to predict for using the winning model at hand. So we make predictions. And then we make more informed decisions in terms of whether or not we send out a retention campaign or retention offer to a particular user. So for each user, existing user, we can make a decision as to whether to offer a retention package or not. So that's how we best utilize our limited resources, marketing campaign resources, by employing this predictive model. So here the context was customer churn prediction, but this set of steps are very generic and universally applicable. So let's say you can certainly apply this set of steps, this process, to a very different predictive model. Say whether a patient has a cancer or not, right? That's how we define the target outcome. Then the rest are identical. We will follow the same set of steps. So you can certainly use this process as a reference for your own project at work or professionally. So you can apply the same set of steps for your own projects. Right. So what types of predictive models are there? To be more specifically, we will continue to use the term supervised to indicate the fact that there is a target outcome of interest. That's what we're trying to predict for. So if there is a specific quantifiable target that you are interested in predicting, then your problem is a supervised data mining problem. And the result of supervised data mining problem is a model that predicts some quantity. It can be exact probabilities. It can be yes or no. Yes, the customer will accept the offer, like a retention offer, and then do not leave. No, the customer is not going to respond to the offer and then leave. So you can certainly make such predictions by conducting supervised data mining. And these are two subclasses of supervised data mining. One, classification, the other, regression. How do we distinguish one from the other? Classification deals with categorical target. Most cases, binary categorical target, like yes or no. Either a patient has a cancer or not. Either customer leaves or stays with us. If that is the key, the target of primary interest, then you have to develop a classification model. When you have a classification model, you can certainly produce some probabilities. So after you've trained a classification model, you can certainly produce what's the chance that, say, Bill, one of my customers, will leave the company or switch to competitor, say 80%, 20%. The probabilities your model produces is numeric, but your target is still binary. What you observe from data is either Bill stays with us or leaves. So that's what determines whether you need a classification problem or model or a regression one. For regressions, regressions basically can handle numeric targets. Say stock prices, they are numeric. So you can certainly build a prediction model of stock price by using regressions. So the key distinction between the two, the nature of target. Either it's categorical, in most cases binary, whether it is binary or whether it is numeric, whether it has no order in it or there is an order in it. So that's how we determine classification from regression and regression from classification. So take a look at these examples. The first one, will this customer purchase service number 1 if given incentive number 1? Is this an example of classification or a regression model? What do you think? In order to answer it, we have to think about the nature, the type of target. What does a target look like? I mean, the target variable look like in this particular case. Either customer purchased the service or not. So that is categorical, yes or no. So the first sentence, the question, corresponds to a classification problem. Okay? And the second one, what is the likelihood that this customer will purchase the first service if given incentive 1? The second one, well, we're interested in the exact probability, like 80% chance or 30% chance. But still, if you think about the target outcome, the target outcome you observe is either customer purchases the service or not, which is categorical, yes or no. So the second question can be answered by a regression, no, a classification model. Right, does that make sense? So sort of, reveal the answers, unmask the hidden answers here. So the first one is a classical classification problem because the target is binary. Second one, to surprise to some of you, it is a classification problem as well because the target is again binary. But from a classification model, you can produce exact probabilities, some, which ranges between, 0 to 100%, well, 0 to 1. And then this one, we have, say, if you're interested in how much will the customer use the service. So it can be like, 3 times a day, or, if it is like internet services, how many megabytes, right? The degree of, or the extent of consumption, is it a categorical variable or is it a numeric variable? Is there an order in it? Yes. Either customer uses a lot or less. There is a degree, there is an order. So this question can be best addressed by a regression problem because target is numeric. Okay. So to recap, we talked about the typical the set of steps you should follow when you build a predictive model. So I sort of illustrate this as a benchmark or reference model, and then we switch to the distinction between classification and regressions. And what distinguishes the two approaches? The nature of target. If it is categorical, then you need a classification problem. If it is a numeric target, then you need a regression model. Thank you.